Hi everyone, this is Muhammad Asjad Ahmad I'm studying from Aeronautical Engineering from Institute of Aeronautical Engineering, Dundigal, Hyderabad. My section is A and my branch is Aeronautical Engineering. So this is my Tech Talk section for linear algebra and calculus. So our topic of Tech Talk is implicit and total differentiation. So this is topic taken from the module 3, differentiation. So it is a big topic. It's a quite big topic, but we will make understand short term as it is Tech Talk. So let us first understand what is implicit function. So implicit function. The so what's the difference between explicit and implicit function? The explicit function is a function in which the dependent variable has been given explicitly in terms of independent variables, or it is a function in which the dependent variables is expressed in terms of some independent variables. So the implicit function is a function in which the dependent variables has not been given explicitly in terms of independent variables, or it is a function in which the dependent variables are not expressed in terms of some independent variables. So by knowing the difference between explicit function and implicit function, we have understood in a very clear manner that implicit function is a function in which the dependent variable has not been explicitly in terms of independent variables, or it is a function in which the dependent variable is not expressed in terms of some other independent variables. It is expressed in on dependent variables only. So this is known as implicit function. So we will understand what's the implicit function by taking difference between explicit function and implicit function examples. So examples of explicit functions is explicit functions are equations where y in terms given as x on right hand side and y on left hand side. Y is equals to 3x minus 2, y is equals to x squared plus 5. So here is the example of implicit function. Implicit functions are y squared plus 2yx plus 2yx 4 plus, here we should get plus 4x square is equals to 0, 5 to the power minus 3x square y square plus 2. So it is of higher orders, it is of lower orders. So it is known as implicit function, and it is known as explicit function. So we have known the difference between these two, implicit and explicit function. So the process of doing implicit differentiation we will understand. So to find dy by dx. So what is dy by dx? Differentiation of y with respect to x. So differentiate both sides with respect to x. Y is assumed to be function and of x. So d by dx is a differentiation. So y here is a function which is given in the question. So collect like terms all dy by dx on the same side. Yes, it is very important. It will not confuse if we do partly simultaneously. If we take all the similar things aside and do it, it would be a bit easier for us to solve the problems, right? So the factor out the dy by dx to solve for dy by dx is, so next we are going to see this if we combine like terms, so it will be given like this c. So we should send it Here it is dy by dx, it is dy by dx, so we have to combine it both. We are getting here equation, then we are sending it down, then dy by dx we got is minus 3y by 3x plus 8y. So that was this is a implicit function with respect to dy by dx. So we have known that this is the process factor. We have found that factor at last. This is the factor of implicit function. So hence this is the implicit function. Now we are going to know about total derivative in this session also. This is our tech talk session and we are going to learn about total derivation also. So what is total derivative? If w is a function, right? So w is equals to f of x comma y comma z so on is a continuous function of n variables x comma y comma z with continuous partial differential equation. See here, it is function here is w, that's why it is placing here. Then for with respect to z y x, we are placing function w as dou of w. So a differentiable function of x is equals to x of t, y is equals to y of t, z is equals to z of t, etc. of a variable t. Then the total derivative of w with respect to t is given by this. This is very important to understand actually. See, dw by dt is equals to d dou w by dx into dx by dt with respect to dx, with respect to dy here, with respect to dz here. So this is the whole equation that we should understand first. So this is the main formula for calculating total derivative. So similarly, for the functions, as we have taken previously, the functions x, y, z, our differential functions of m independent variables will be r, s, t, and so on. Then, so here with respect to r, you're taking r, then you're taking r, and you're taking r. With respect to s, we replace s with each differential part we are using it. So now note the similarly between the total differentials and total derivatives, the total derivatives above can be obtained by dividing the total differential by dt, comma dr, comma ds. So yes, this is so if we this if there is no denominator here of or else we have taken it and cancelled it out, it will be like this, the equation will be. So at last we have known about implicit and total derivatives. So it's end of our session. We have gone through examples of each topic. So it may clear your doubt. So thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.